Different evaluation questions need different detectors. Rules verify known facts, baselines reveal unusual change, and LLM judges assess contextual quality. I'm Mehrdad. Let's build an evaluation stack that uses each detector where it is strongest. Do not begin by choosing the most capable evaluator. Begin with the question: did a known rule break? Is this behavior unusual for comparable requests? Does the output actually satisfy the user's intent? Those are different measurement problems. One universal grader would blur direct evidence, statistical suspicion, and contextual interpretation into the same kind of score. Use rules for facts, baselines for change, and judges for meaning. The request is specific. Plan 3 Boston days for 2 adults and 2 children, under $1,800, near the Science Museum, with no booking before approval. A planner delegates searches, an activity agent proposes stops, and a coordinator builds the itinerary. The policy checker can verify authorization and budget. Telemetry can show repeated searches and rising tool cost. Neither can decide whether 2 museum-heavy afternoons suit the children, whether transit is exhausting, or whether the rain plan is credible. The same execution trace therefore feeds 3 evaluators, but each receives a deliberately narrower question. If this framework is useful, like the video and subscribe to Multi-Agent Academy. Start with conditions code can verify directly. Did an action run before required approval? Did total cost cross the budget? Did a tool run before its dependency? Did a duplicate write reuse identical arguments against unchanged state? Each result should name the rule, show the evidence, identify the affected task, and say whether to block, warn, or record. This makes the finding reproducible and lets an engineer inspect the exact event that triggered it. Sequence checks need context. Repeating an identical tool call becomes concerning when state does not change and the task-specific retry allowance is exhausted. Repetition alone is not proof of a harmful loop. An unauthorized write is a confirmed policy violation. A repeated call may be a structural defect, a harmless retry, or an idempotent lookup. Structural evidence can be direct without being severe. Impact is a separate question. Rules can prove a known invariant broke. They cannot tell us whether 12 calls are unusual for this request. Unusual behavior needs a reference population. 7 tool calls may be excessive for a short request and perfectly ordinary for a long, multi-step one. Build baselines from representative, healthy runs, then stratify them by request type, difficulty, model, prompt, toolset, environment, and release. Compare path length, calls, tokens, latency, retries, replans, and recovery rates within those classes. Baseline health also needs review, because contaminated examples can make poor behavior look ordinary before monitoring even begins. Freeze or version the reference with each release. Otherwise, a system that slowly becomes less efficient can teach the detector that degradation is normal. Agent telemetry is often skewed, heavy-tailed, autocorrelated, or mixed across several operating regimes. A global average hides that structure. A 28-call run may sit far outside healthy peers even when the final answer remains useful. That makes it a statistical anomaly, not a confirmed defect. The next question is whether it was one spike or a persistent shift. A point threshold asks whether this run is unusually high right now. Robust quantiles, or median absolute deviation, can help when the distribution is skewed. Slow drift needs memory. An exponentially weighted moving average, or EWMA, gives recent observations more weight while preserving history. A cumulative sum, or CU sum, accumulates small departures across runs. Both can expose a release-by-release rise that no single request makes obvious. Detector choice should follow the failure shape and the operational cost of false alarms or missed drift. One extreme run may deserve observation. A rising median across several releases deserves investigation, especially if outcome quality stays flat. These methods illustrate useful shapes, not plug-in guarantees. Choose and validate them against the actual telemetry distribution. A detector result is not an incident priority. Track 3 quantities separately. Confidence asks how directly the condition was measured. Impact asks what harm follows if it is real. Persistence asks whether it is isolated or recurring. An unauthorized write is high confidence and high impact, so block it. A confirmed duplicate lookup can be high confidence but low impact, so log or ticket it. One latency spike has weak evidence of a broader problem. These dimensions also decide whether to observe, investigate, gate a release, or stop an action immediately. Structural confidence is not impact severity, and statistical surprise is not proof of failure. Escalation should preserve those distinctions. Some criteria genuinely require interpretation. Is the plan usable for the stated constraints? Does it resolve conflicting recommendations? Is the burden reasonable? And does the contingency preserve user priorities? For those questions, use a rubric-constrained language model judge. Do not ask, "Is this good?" Give the judge one criterion per score: observable trajectory evidence, explicit score anchors, and a reference answer or policy when one exists. Include an insufficient evidence option. For pairwise judgments, define what a tie means instead of forcing a preference between equivalent outputs. Freeze the model: version, prompt, evidence format, and decoding configuration. The rubric defines the question and reduces ambiguity. It does not make the judge deterministic, factually correct, or capable beyond its underlying reasoning. Keep authorization, budget, and exact arithmetic outside the judge. Validate semantic grades against human-labeled examples from this actual task. Now test the evaluator itself. Present the same two answers in reverse order, and record whether the preference flips. Add irrelevant detail to one answer without improving its substance. Change style or claimed source while preserving content. Compare outputs from the judge's own model family with outputs from another family. The verdict should remain stable when quality remains stable. If it moves, that sensitivity is a judge health signal. Controlled perturbations isolate evaluator behavior more cleanly than comparing unrelated answers whose quality also changed. Research documents position, verbosity, style, and self-preference effects, but their direction and magnitude depend on the task, judge, candidate gap, and comparison protocol. Do not copy a universal bias rate into production. Measure the deployed judge under the deployed rubric. Order swapping and empty verbosity padding become regression tests whenever the judge model or prompt changes. Fixed prompts and low temperature reduce one source of variation, but they do not guarantee identical grades. Repeatability must be measured. Run threshold adjacent examples several times, then report agreement, score dispersion, and the rate of operational decision changes. A single score of 3 should become a small distribution with visible uncertainty. Compare that distribution with human-labeled calibration cases, especially near any gate that changes production behavior. When repeats disagree, revise the rubric, add another evaluator, or route the case to human adjudication. Revalidate after changing the judge model, prompt, rubric, evidence format, or domain. Temperature 0 is a control, not a guarantee. The supporting reproducibility study is an emerging preprint with a narrow borderline set, so it motivates testing rather than establishing a universal failure rate. Combine the 3 evidence streams without collapsing them into one score. Rules may show no unauthorized write, while still identifying repeated tool calls without state change beyond the allowed retries. A stratified baseline may show unusually high calls for healthy peers and a persistent rise across releases. A rubric judge may find the final output usable, but the coordination evidence weak. Those methods cover different failure surfaces. Agreement raises confidence that the system needs investigation. Disagreement can also be useful because it identifies the boundary where evidence, rubric, or baseline design needs work. It does not guarantee the diagnosis is correct. A panel of different judge families can reduce dependence on one model, but shared data, prompts, and factual gaps can create correlated blind spots. Ensembles do not create ground truth. Combined methods improve coverage, not guaranteed accuracy. Meanwhile, one isolated latency spike can remain an observation instead of borrowing severity from unrelated signals. This closes the multi-agent evaluation series. We started with failure modes, moved through behavioral consistency and causal reconstruction, and finished by matching each question to evidence it can support. The operating principle is simple. Use the cheapest detector that can falsify the behavior, then escalate according to confidence, impact, persistence, and corroboration. Never let the most articulate detector become the only detector. If this series helped you, subscribe to Multi-Agent Academy and connect with me on LinkedIn. I'll keep publishing evidence-backed work on agentic systems. We matched each question to evidence it can support. I'll see you in the next deep dive.